So here's our first problem that you're responsible for, 516A. It says potassium chloride is available as 3 million micrograms per tablet. Okay, so you're administering tablets here. This is a regular tablet, right? Maybe it has a little line through it. But anyhow, this tablet contains 3 million micrograms. 0.021 kilograms is ordered. So that's the dose you need to give. So we're trying to find out how many tablets, each containing 3 million micrograms, has to be administered. So the first thing we have here, this is the conversion we have. 1 gram is 1 million micrograms. But the order came in 0.021 kilograms. So we can change kilograms pretty easily to grams, right? Because that conversion is and I would give this to you on a test. 1,000 grams equals 1 kilogram. So let's first turn this into grams. So I'm going to use dimensional analysis, means I'm going to multiply by 1. But what goes on the top here and what goes on the bottom? And you should know by now that the kilograms have to go on the bottom because they have to cancel. And the grams go on the top. So I got 1,000 grams per 1 kilogram. So multiplying 0.021 by 1,000 moves the decimal 3 places, so I don't even need a calculator, and I got 21 grams. Now I'm going to take my 21 grams and convert them into micrograms. There's my conversion. Use dimensional analysis. What goes on in the numerator and the denominator? And if you guessed grams in the denominator, because the grams must cancel, you'd be correct. So that means micrograms go in the numerator. And it's 1 million of these for every one of these. And so I'm going to get 21 million micrograms. That's the dose. Now each tablet contains 3 million micrograms. So hopefully you can see that you're going to divide. And I can actually do this with units too. I can say 21 million micrograms times 1 tablet per 3 million micrograms. And the tablet and the micrograms are cancel, and I get 21 million divided by 3 million, which is 7 tablets. And because this is the conversion here too. 1 tablet equals 3 million micrograms. All right, these are not hard, but you have to understand what it is that you're doing. And I'll try to walk through this with you. So this is the medicine, and that's what's ordered. And this means 1.5 milligrams for every 1 kilogram the patient weighs. So that is what was ordered. It comes in this kind of amount. It's a solution, right? Milligrams is weight, that's the active ingredient, and milliliters is like it's either water or some kind of solution. So this many milligrams is mixed into this many milliliters. So this is how it comes. 125 milligrams per 2 milliliters. So what we've got to find out, here's what the doc ordered, and we have to find out how many kilograms the patient weighs. Now, the child weighs 74.8 pounds, but that's not going to help us. Again, I would give you this conversion, which is 2.2 pounds equals 1 kilogram. So the first thing we're going to do is change the weight of the child to kilograms using this conversion factor. And what goes on the top and what goes on the bottom again. If you guess pounds go on the bottom, you would be correct because the pounds have to cancel because you want kilograms. So that would be 1 kilogram, 2.2 pounds. So this is 74.8 times 1 divided by 2.2. And I'm getting 34 kilograms when I put it in my calculator. So if you're going to get 1.5 milligrams for every kilogram, and the patient weighs 34 kilograms, I can just use dimensional analysis again. I could use a proportion. Cross multiply and divide. But you're going to get the same thing. The kilograms cancel, and it's really 1.5 times 34 on your calculator. And I'm getting 51 milligrams. So that's how much of the active ingredient I need. They don't administer the active ingredient, they administer the solution, which contains the active ingredient. So in this case, I am going to say it's 125 milligrams for every 2 milliliters. So therefore, if the patient needs 51 milligrams, then how many milliliters should I administer? And you're going to cross multiply. 125 times x equals 102. 2 times 51. Divide by 125. Divide by 125. The number of milliliters is equal to 102 divided by 125, which is 0.816. I'm going to put 0.82 milliliters is how much must be administered. It's less than 1 milliliter. There's nothing surprising about that. Okay, so we're doing part B. There's 2 of these because they're tricky. The math is simple. What's tricky is understanding the problem, okay? So a doctor orders 200 milligrams of this medicine to be taken by a 15.4 pound infant every 8 hours. The medication label, right? The label shows that 75 to 150 milligrams per kilogram per day is the appropriate dosage range. Is the doctor's orders of this within the desired range? So nurses are supposed to, they have to check this stuff. So there's a double check on medicine. So this means 75 to 150 milligrams for every 1 kilogram of the weight of the patient per day. So in order to see if it's in the desired range, we got to figure out, first of all, how many kilograms this infant weighs. And again, here's the conversion. 2.2 pounds equals 1 kilogram. So if the patient weighs 15.4 pounds, I'm going to use dimensional analysis. What goes on the numerator, what goes on the denominator? If you guess pounds goes down here, you'd be correct because they must cancel. So we get kilograms. Right? So I'm going to go on my calculator and go 15.4 divided by 2.2. And I get 7 kilograms. So the infant weighs 7 kilograms. So now we're going to figure out, it's being given 200 milligrams every 8 hours. And there's 24 hours in a day, so there's 3 doses here. So the child is being given a total of 600 milligrams, and the child weighs 7 kilograms. So if I divide this, I'm going to get milligrams. If I divide it, I'm going to get milligrams per 1 kilogram. And then I can compare this to the actual dose, the daily dose. So I'm going to go on my calculator and go 600 divided by 7, and I get 85.7. 85.7 milligrams per kilogram per day. And that is within the desired range. Okay, so another medicine problem. These are the math's not hard on these. What's hard is the reasoning. So they're reasoning problems. So they're prescribing 12.5 milligrams in 250 milliliters. So that is the medicine, and that's the liquid that the medicine is dissolved in. It's dissolved in 250 milliliters. And it's going to be infused at a rate of 6 milligrams per kilogram per hour. The patient weighs 100 kilograms. What is the flow rate in milliliters per hour? So it's where you set the pump. So let's just get an image here. So that's like a bag in a hospital. And there is the solution. The solution contains 12.5 milligrams for every 250 milliliters. And it usually has a tube that drips out. And there's a pump setting. And then the pump goes into a person's arm usually. There's their fingers. It goes into their arm. And we're going to set this pump here. So here is the infusion rate. 6 micrograms per kilogram per hour. So the patient weighs 100 kilograms. So let's figure out at least how many micrograms are going to be administered per hour. Because this means that much of the medicine for every kilogram the patient weighs. So if the patient weighs 100 kilograms, how much micrograms should they get? Cross multiply and divide, and you're going to get 600 micrograms. You can also do this with dimensional analysis. Weighs 100 kilograms times 6 milligrams for every 1 kilogram of weight, and you get 600. So this is the hourly rate, right? So we know we're going to try to find out how many milliliters an hour that represents. So we have 12.5 milligrams for 250 milliliters. So that's proportional to 600 milligrams for every X milliliters. But notice that's micrograms. And you can't have milligrams, milliliters, micrograms, milliliters. So I'm going to change this 12.5 milligrams into micrograms. So then I have micrograms, milliliters, micrograms, milliliters. The conversion factor is 1,000 micrograms equals 1 milligram. And I didn't give that to you in the problem, but that is what I would certainly give you in any problem that you would see. And I got that by knowing that there's 1 million micrograms in 1 gram, and there's 1,000 milligrams in 1 gram, so that would be the relationship. Use dimensional analysis, what goes in the denominator? If you said milligrams, you're right, so they cancel. That's 1,000 micrograms. 1,000 times 12.5, move the decimal 3 places. 1, 2, 3, and I get 12,500 micrograms. So I'm going to rewrite my portion here. 12,500 micrograms per every 250 milliliters equals 600 micrograms for every X milliliters. And I'm going to cross multiply and divide, and you can do that on your own, and give you a minute here and see if you come up with the same answer that I do. And if you got 12 what though? Milliliters. So that's the flow rate that you would set the pump at, 12 milliliters per hour. So here's our last problem, and it's diluting a solution. I just want to go into a little about a solution. Let's say it's salt water. Well, the water would be, the salt would be the solute, and the water would be what the solute, in this case salt, which is NaCl, right, is dissolved in. So you got this much, and you got this salt, which is actually dissolved. Right? It dissolves. It's not like sand in water where it floats around. It dissolves in the water. So you have 5 liters of the solution. So let's say that's 5 liters right here. And it's a 35% chemical solution. So 35% of this solution is, well, we'll say salt, right? So if there's 5 liters total, how much is the solute? If 35 out of every 100 particles, which that's 35%, is the concentration. So I'm going to cross multiply and divide here. And I get 100 times X equals 150, 175. Divide by 100. Divide by 100. and X is 1.75. So the solute, or the salt, is 1.75 liters for every 5 liters of the solution. That's pretty salty. And I want this to actually be equal 15 over 100, right? I want to dilute this. I want to take it and dilute it so that it equals this. So what am I going to do? Well, the only thing I can do is to dilute it is to add water. In this case, I'm just going to add X, which is the water. So I'm going to keep adding water to this so that this equals this. So how am I going to do that? I'm going to cross multiply. 1.75 times 100 is 175. Now watch this. This is 15 times 5, which is 75. I'm going to write it over here. 15 times 5 plus X. It's the distributive property from Algebra 1. 15 times 5 is 75, plus 15 times X, which is 15 times X. So it's like an 8th grade algebra problem now. What do I do first here? Well, if you guess subtract 75, you would be right. So I get 100 equals 15 times X. What do I do next? Divide by 15. Go on my calculator, and I get, round it, I get 6.7 liters. So let me just make this clearer in terms. I'm going to add 6.7 liters down here. Okay? I'm going to clear this off a little bit. I'm really going to check my work here. So I have 1.75 liters of the solute. And now I added 6.7 liters down here. So that would be 11.7 liters. So let's see what my concentration is per 100, the percentage of concentration. And I'm not asking you to do this, I'm just doing this for you to check this here. So how do I do this? Well, I cross multiply, I get 175 equals 11.7 times X. Divide both sides by 11.7. Put that on my calculator. And I get, what do you think I get? Well, if you guess 15, you'd be correct. Actually, I got 14.957. A little rounding error, but that is fine. So here's problem 1. It says if you add 8 ounces of water, 8 ounces of fertilizer to 5 gallons of water, what is the concentration? Which a concentration is given in a percent per 100 ounces of water. There are 128 ounces in a gallon. Now we're going to go ounces to ounces. And why is that? Because I can't say if I have 8 ounces of fertilizer and 8 gallons of water that would be 100% concentration, right? That doesn't work. So I got to change 5 gallons to ounces. Dimensional analysis. Here's the relationship. What goes on the bottom? Gallons. And 128 on the top, ounces. So 5 times 128, gallons cancel, is 5 times 128 on my calculator, and I get 640 ounces. So I have 8 ounces of fertilizer for 640 ounces of water. I don't want to know the concentration. The concentration is parts per 100. It's a percentage. So I'm just going to set up a proportion. Put that there. Cross multiply. And I get 640 times x equals 8 times 100. And that's going to be the percentage, whatever you get out of that. Okay, so I'll get you started on 2 and 3. It says a certain antihistamine is prescribed for allergies. A 100-pound person is the dose, right? For a 100-pound person is 19 milligrams every 6 hours. How many 13.7 milligram chewable tablets would they take in a week? Well, first let's find out how many milligrams they take in a week. If they have 19 milligrams for every 6 hours, you would take 4 doses, because there's 4 6-hour periods in a day. And then you would take that for 7 days. And that would give you how many milligrams per week. And I think I gave you too much on that, but there you go. So here is a prescription for 30 milligrams per kilogram per day in 3 separate doses. So every 8 hours. For a person weighing 60 pounds. Well, you got to come, here's the conversion. 2.2 pounds equals 1 kilogram. So first of all, you need to change their weight from pounds to kilograms. Most medicine is this is the way it is. And the medicine is available 100 milligram tablets. How much is to be given per dose? Per dose. That's every 8 hours, not every day, right? So change their weight to kilograms, and then you're going to get actually 10 milligrams per 1 kilogram, and that is the dose, right? Because it's 30 for a day, so it's going to be 10 for every 1. So how many milligrams are you going to get for whatever their weight is in kilograms? Convert here to kilograms. And then you know how many milligrams they're getting in a dose. And each tablet is 100 milligrams, so the question is how many tablets? Well, I don't want to give too much away here, but I will do a few things. So it says a 17% dextrose solution. And this is weight per volume. Is given intravenously. 4 liters is given over a 24-hour period. How many milligrams were delivered over 24 hours? Well, that's just simply this, right? Cross multiply and divide. And you get your milligrams. And the flow rate in milligrams per hour. Dextrose is the medicine. Well, if you know how many milligrams in 24 hours, it would just be, right? How many milliliters of the solution were given in 24 hours? Well, you were given 5 liters, and there is 1,000 milliliters in 1 liter. So you can use dimensional analysis here, right? What goes on the bottom? What goes on the top? And the flow rate in milliliters per hour is, this is 24 hours and this is 1 hour. So it's the same as up here. Well, again, I don't want to give too much away, but I don't want to be completely confounded either, right? So this is a 1 gallon, 128 ounce, 10% solution of fertilizer and water. Solute is what's being mixed up in it. It's either the medicine or the actual ingredient, and water is where it's being mixed up in. So if it's a 10% solution and you have 128 ounces of water, it's 10%, meaning 10 over 100. How much fertilizer? Cross multiply and divide, and you're going to get this. Make sure you can do that. And understand what I'm doing here, right? That's 10% of this. And you want to dilute it to a 2% solution. So you have to add water. All right? Add this so that this here equals 2 over 100, 2%. And again, the way you cross multiply with an x would be, that's 2 times 128 plus x, which is 2 times 128, which is 256 plus 2x, right? And that would go on one side of the equation, and 100 times that on the other side. This one is dilute a 25% chemical solution of 4 liters. Well, let's find out what the solute is. If the solution has 4 liters, and hopefully you can see that, you can cross multiply and divide, and you're going to get 1 liter to 4 liters. And you want that to equal 15%. And you're going to add here, add water or add X, whatever. So it's the same problem as this one here.